David.
Thank you. So I thought I'd take about 20 minutes away from coding to tell you where things are at, where we're going. If you've been following all of my talks and the discussion on the mailing list, then some of this stuff won't come as a big surprise, especially towards the beginning. But I'm really excited to talk about some of the architectural decisions we're making and some of the stuff under the hood that just is going to make this a really firm foundation for the best UI framework out there. The big picture. There we go. So the current batch of work we're doing is a new rendering model. It basically affects how templates get rendered and updated, all the patterns for that. And we're trying to keep it so the API changes are minimal, but this will affect how people write their apps and really make things a lot easier because often, especially with interactions with third-party libraries and jQuery and embedded widgets and stuff like that, you do run into rendering problems where maybe part of your DOM's being re-rendered more than you'd like. So this offers fine-grained DOM updates and better jQuery interop are kind of the big ticket items here. These other 3 points are stuff that's coming down the pipe. It's stuff we're thinking about. Components, where you can kind of marry a template to a controller, meaning you have some local reactive state, you have some logic that makes your template kind of modular, and making these configurable and overrideable, which is really, if you do some deep thinking about what it means to have a UI component, a lot of it is how do you make this reusable in different contexts. Right now, if you define a template, you can use it for multiple places in your app, but you can't really set configuration parameters. You can't override parts of it. You can't have state that's local to each instance of the template. Well, you can, but the patterns for it aren't very convenient. So that's kind of where we're looking to and what a lot of this stuff is based on. But because we're overhauling the rendering model as part of all this work, we want to kind of get that out first and kind of lock down some of that. Animation hooks, something we're thinking about. Probably not going to be in there for 1.0, but for a forward-looking framework like Meteor UI, it's very important that we can imagine what it should look like, where it's easy to specify animations, it's easy to fire them off programmatically, have them take effect declaratively, custom animations. Frameworks like Angular have animation systems, but they're not that great. I think we can do better, so we're keeping that in mind. And down the line, we are going to have some exciting enhancements to templating. We're thinking about having inline expressions, so you can kind of do if statements, do math inside a template, and pluggable syntax providers. So you'd have a Jade-like syntax, different syntaxes for your templates. So that gold box, the new rendering model, is what we're working on and releasing first, and that's mostly what I'm going to be talking about today. So just to go over the old rendering model, just very concisely. In the old rendering model, it was considered okay to over-render templates, essentially. I've got a template here that has a title. It's basically some reactively generated text. I've got a reactive attribute, foo, and then I've got this template main at the bottom that invokes the main pane template with the data argument of my info. And it used to be that title changes, that re-renders main pane. If foo changes, that re-renders main pane. If the data argument to the template changes, that also re-renders the template. And the reason that's okay, even though we have this input element in the middle that we probably don't want to mess with, we had the patching algorithm whose goal is to not ruin inputs, widgets, and embeds through these replacements. And it required these hints. So like element IDs and names are significant. You can write your own preserve directives, and you can use this constant region thing that a lot of people have to use. And that was impressive computer science, but we decided that's too complicated. So new rendering model starts with isolating everything. So helpers in attributes, helpers not in attributes are isolated. They're recalculated and then patched into the DOM right there when they change. A data argument like myInfo doesn't necessarily cause any DOM changes, so that doesn't necessarily cause any re-rendering. Basically, the dependencies are passed along to the parts of the template, and if those change, then the DOM is updated. There are, of course, cases where you have to replace a whole range of the DOM, and we want to do that sparingly because we're not having patching anymore. It's basically, if part of the DOM is replaced, it's because of an if or an each, it's because of a custom block helper, and kind of lumped into that is dynamically chosen templates, like you have a blog or you have a routing system where you want to calculate programmatically what template to display. If that changes, then of course the old template goes away and the new one comes in. But that's basically it. So it's a simpler model, has some major benefits. Reactive attributes are more interoperable. You have things like Bootstrap that want to change attributes on elements, set classes, stuff like that. Templates are never re-rendered from above, so you don't have this problem that's a big problem for modularity where you have to write your templates assuming they might be completely reconstructed based on dependencies higher up in the DOM. And templates don't care if you modify their DOM. This is basically the death of the constant region. If your template has a div, you can put stuff inside that div. It could be like a Google map. It could be a different template that you've dynamically inserted because of, Iron Router's layout system, say. And the template doesn't care. The template, assuming it doesn't have to re-render, it'll just leave that content alone. And the patching algorithm was one of the big reasons we couldn't do that before, because the patcher would come along and it really didn't know how to deal with stuff it wasn't expecting to see. And this model is easy to reason about. There may be some times where something's re-rendering, you don't want it to. That's certainly the case now with the old, the currently released code. So basically the difference will be you can track down where that's happening and know what to do about it. There's also some major changes that will affect how templates are written. And this is really, I've spent a lot of time thinking about these deep questions. What is template.foo? What does hash foo mean? What does greater than foo mean? It may not be obvious why it's important to think about these things, but a lot of it's come out of thinking ahead to a world of components and how those will be defined. Components might have template parts that you might want to insert them in different ways. So template.foo, one of the big changes, it's no longer a function. It's not a function that returns HTML. It's some sort of object that knows how to create HTML. It knows how to create DOM. And we're kind of like not committing to too much about template.foo, except that it does continue to support all the APIs you use, template.foo.events, .helpers, .created, all that stuff. But under the hood, we're working towards a future where it's a component class and where that's what it really is. And I've got some code examples of things that you can't currently do in the release code. You can't set a helper called greeting, say template.main.greeting, and have that helper be another template. And the reason you can't do that is because when you go to insert a template, when you type greater than greeting, it doesn't search the helper namespace. But you currently can do that on the branch we're working on. Another thing is template.main2. Here what we're doing is we're extending an existing template and we're replacing part of it with a different template. And that's hugely useful. That's, for example, we have a login buttons package right now. It's one of our only UI widget packages. So you drop in login buttons in one line, and then from there you customize it with CSS. Well, you can't customize the templates. You can't take a package that uses some templates and override just some of those templates while using the other ones. So that's actually really powerful. And that code also works on the branch, but with the warning that this is an experimental API. Template.main.extend hasn't completely settled yet as an API. But what we're doing is we're experimenting under the hood with this question of components and inheritance because we know that's where this is going. We know we're going to have inheritance between components and mixed in behaviors and stuff like that. Hash foo and greater than foo. You use hash foo right now for block helpers like if, else, with, and custom block helpers if you've experimented with defining those. Greater than foo you use to insert a template. So the changes there are that both of these are going to be searching the template namespace and the helper namespace. You can have helpers that are templates. You can have templates that act as block helpers. It may sound confusing, but basically it's going to give a lot of new flexibility for cases like forms. This is kind of the example of a type of syntax for forms that we've had sitting on the corner of our whiteboard for a long time of like, we want it to be this easy to make a form. You have a block helper that's like the boundary of your form. Maybe it sets events. Maybe it has the state of the form fields. If you want a text box, you insert it like it's a template, but actually it's a component. And we don't have all the details of this worked out, like what is address, what is street, how is the reactive state stored. But what we're enabling is these things to be components. And what if you want your own kind of text box? What if you want to use the behavior someone else has written in a text box, but you want to subclass it? Or maybe text box is actually supplied by my form. Maybe you can have a form block helper that defines some of its own local components and then exposes those. So there's all sorts of patterns we might want to have here. And what we don't want to do is have to add new syntax down the line or suddenly realize that we don't have a component syntax and we need components. So if you have custom block helpers, if you're curious about these changes and how they will affect you, you should definitely check out the mailing list. I'll have some pointers at the end of the talk, but there's a wiki page on the changes. If you're on either Meteor Talk or Meteor Core, you probably saw an email go by and there's a whole thread going with people trying out the code. Under the hood, I think under the hood is actually the more interesting part because, yeah, it affects the syntax in this way or that, but we've done a complete full stack overhaul as far as the UI stuff. We have a new template parser and compiler. The code name is Spacebars. I don't know, it's just the code name. We have a reactive rendering abstraction. This kind of replaces Spark. It's called render buffer. Live range is replaced by DOM range. And we have an experimental class system that implements the sort of inheritance I was talking about. And we're not talking too much about that because it still kind of hasn't settled. So here's a sort of schematic of the old pipeline for taking in a template. The part to the left of the blue line happens when your project is built. So your template is parsed by handlebars parser. Which spits out an AST, which is an abstract syntax tree. It's basically just a JSON data structure representing the parsed template. When the code actually goes to run on the client, the handlebars interpreter pulls up that data structure, it walks through it, it makes calls to Spark. Spark makes calls to live range, and that's kind of how everything happens. The new pipeline is significantly different because instead of a parser and this data structure that's sent down, in the build step, your templates are actually compiled. And they're compiled to code that calls this render buffer API. So you have compiled JavaScript for all of your templates. You can view this in the source inspector in Chrome. At some point, we might even have source maps. So your handlebars template shows up in the source pane of your browser. We can do all that because it's compiled JavaScript. And then when the compiled JavaScript goes to run on the client, it's calling into this new API that's the render buffer, and the render buffer uses this new thing called DOM range. And so here's a cool thing we can do. DOM range can talk to jQuery, and it can support animation hooks. And these are kind of bidirectional, multi-directional interoperation. So if you remove part of the DOM through jQuery, assuming you're using jQuery, if you remove part of the DOM through jQuery, Meteor can find out about that. It can hook into jQuery. In the other direction, if you have something like a jQuery UI widget you've embedded in your page, and it's listening for jQuery to tell it when some DOM has been removed, we will actually send the appropriate notifications to jQuery to make sure that that all happens correctly. Animation hooks means that if Meteor is doing some structural operation, like an if is changed and each needs to be updated, you'll be able to hook that, and you'll be able to use jQuery in those hooks, and all of that will just work. Also coming in the future is the prospect of other template languages, which compile JavaScript. Basically, we're creating the perfect target for other template engines. So if you want to have other syntaxes, if you want to have other template engines that also consume HTML, like EJS or something, that will all be possible. This API is also something you can write to by hand. It's going to be what's in your block helpers and custom components if you want to use it. What does that API look like? Well, I was working on cleaning it up this week, and I was hoping to have a really cool demo where I open the inspector and everything looks amazing. But what's coming is this syntax where you can declare your HTML in this nice kind of functional style. And this will be actually what your templates compile to. This will be what runs them under the hood. And you can also, write fragments of HTML in this form if you want. This also puts Meteor UI on a nice footing where it doesn't depend so heavily on Spacebars and the build process, because you could imagine using this API outside of Meteor in other contexts. And this is sort of a lot like what other frameworks are doing. Like Facebook's React framework essentially has a syntax like this. And then what they do is they have this syntactic sugar on top of this syntax that lets you write HTML tags in your JavaScript. That's not really our style to parse HTML in your JavaScript code. We have .html files for that. And we also want to support different template languages. But the idea of having this intermediate representation that's kind of a target for HTML compilers, I think is sound. It's more HTML aware than Spark. Spark didn't really know about HTML attributes that much. It didn't really know when you were in a text area or a style tag. It kept us from making some of that stuff reactive. So yeah, there's a bunch of kind of reactivity features that this will let us do. And in the future, we can also be smarter about SVG, which we have sort of partial support for right now. But with the popularity of things like D3 and Reactive, and the fact that we have a reactive system, you can imagine that SVG would be a very appealing thing to be able to just drop in. And an interesting thing about this example is that this function literal is essentially like a spark.isolate. So it's this little kind of domain-specific language where every time you have a function literal, it just becomes reactive. And I look forward in a future talk to talking more at a lower level, because I think this is really kind of at the heart of the new Meteor UI. And there's a way, when this API is ready, I think a documentation of this API will just make it so Meteor UI is a very graspable thing. It's very okay, you've got all this template parsing stuff. We don't really know how that works, but it spits out this representation. And then this representation just makes your DOM reactive in particular places. And we don't know how that works either, but it's pretty clear what's going on there in the end. Since I mentioned replacing DOM range with live range, I'm just going to replacing live range with DOM range. I'm just going to try to show quickly pictorially what that difference looks like. So here we have a list. Inside that list, we have an each. Inside that each, we have an if that maybe sometimes spits out a list item, sometimes doesn't. And these white boxes represent the live ranges that you get in the DOM. You can't usually see these. They're kind of very tucked in. But if you've looked at Spark or watched some of Chris Mather's videos, you might have seen some of this. So live range has these strong bidirectional pointers. It kind of assumes the DOM is going to be pretty much how it left it. You can see that if you were to just come in with jQuery and really shake up this DOM, remove an LI that's on the end here, move them around, it would just move these pointers around. That would be a disaster. So what DOM range is, it's a lot more like a kind of spider web that ties together these constructs between two levels of the DOM. So you've got the UL, you've got these LIs, and in between you've got this kind of bookkeeping that has to know that there's these eaches and ifs are there, so it can go in and toggle them if something becomes visible, if a new item gets added. But all the pointers pointing down the tree are weak pointers. So if you come in with jQuery, you remove an LI, you move these around, everything is still consistent. And we have even more ambitious plans for how this is going to work with jQuery and animation, where you can do even more than that. You can move these through Meteor and jQuery. You can have like jQuery removing something and Meteor trying to add something, and it'll all just work. Okay, so I'm running out of time. Status is being developed on the Shark branch. It already runs most of our example apps, which is a big milestone. There's a lot of discussion on the mailing list, and there's a wiki page about the user-facing changes. We're preparing release tags. So, on the mailing list, this is something we like to do where you say, okay, now try your code with template engine preview 2. And if you pass this flag to Meteor, it'll run the app with a different release than the mainline release. And you can also use this with like Meteor deploy. You can deploy code on different releases, all without using Git. So in the interest of not over-promising, I'm just going to say coming this holiday season, I'm working around the clock on it, basically, and trying to see how soon I can land it on Devel so we can start hacking more on it, and then how soon I can get it released. So thank you. Are there any questions? Yeah.
What is strong and weak pointers?
Oh. A weak pointer, The question was, what are strong and weak pointers? JavaScript doesn't have weak pointers. I wish it did. I think it's going to get some form of weak pointer at some point. The idea is basically you're pointing at something, like you're pointing at an object, but you don't care if that object goes away. And in particular, in garbage collected languages like JavaScript and Java, it means you're not retaining that object. You're not keeping it in memory. So weak pointer to something is you can get to that object if it's still there. If the object happens to go away, then you try to follow it, and usually you can check. You can say, is this still there? What it means applied to this case is that basically a DOM range is prepared for the elements in it to go away, and if every time it goes to follow one of these pointers, it looks to see if the DOM element is still in the DOM. If it's not, it throws up its hands and says, oh, well, I guess that's gone. It tears down the pointer. And in some cases, it'll actually keep a placeholder because it might, if it needs to do some re-rendering, it wants to kind of get to some reasonable state. But yeah, that's basically the answer. Yeah?
So the compiled JavaScript that you showed, the format where you have like h1 and it takes a function and it returns a session variable, that stuff's all really useful for Meteor, right? And presumably that's what Spacebars will compile to.
Mm-hmm.
To what extent would it be useful for someone to write a handlebars compiler and a J compiler that have nothing to do with the reactive data sources? Or would it be easy, or how big of a, like, how hard would that be?
I don't quite understand.
So how hard would it be to write Spacebars without any of the reactive stuff so that you can use it with Jade, or use it with EJS, or use it with Mustache, or use it with
How would you use Spacebars with Jade?
Well, so Spacebars is a handlebars compiler.
Essentially.
Right?
It's a handlebars-like compiler.
Yeah. And then say you wanted to use Jade. How much work would I have to put in?
Oh, to make a Meteor package for it. Oh, so the question was, how much work would it be to create a Meteor package for something like Jade, given this API? Is that right?
No, how hard would it be to take a Jade template and compile it to the same format that Spacebars spits out?
Yeah. Yeah, I mean, the goal is to make that really easy, essentially. Yeah, so yeah, the question was, how much work would it be to write a Jade compiler that compiles to the same format as the Spacebars compiler? I think the answer is it should be really easy. Like the sacrifice we've made since Spark is we were originally trying to make it so we could reuse the same implementation. So if someone had a Jade library that had a full, maybe it had a parser, a compiler, an interpreter, or whatever, and it would build up strings and buffers, that we would somehow be able to be completely ignorant of those inner workings and still magically make it all reactive. And what we're doing now is saying, like, we do want visibility into the elements. We do need to know the structure of the HTML. But we think we can separate the syntax of what you type from all this hard reactive stuff and make the syntax part really easy. And in fact, it's a lot easier to write a Jade parser than a handlebars parser, because an HTML-aware handlebars parser has to parse HTML, whereas a Jade parser just has to look at indentation and tag names, and the syntax is much more straightforward. So I think that should be really easy. Yeah.
You've been following the work that Google's doing with Polymer and Mozilla's doing with Xtags to create web components. And
Yeah.
how might that work with Meteor UI?
The question was, have I been following the work from Google in the form of Polymer and from Mozilla about web components, and how does that fit into this? I'm kind of keeping an eye on that. I think to the extent that some of it's based in extending browsers, I think that really gives me pause, because we work really hard to support the features that are already in existing browsers, going back to Internet Explorer 8 even. So to say that maybe at some future time browsers will have custom elements that inside the browser are expanded to other elements, I think that would be interesting. It's an interesting implementation technology to use for something like Meteor. I don't know if it's the right way to express components, to express the things you can currently express with templates like handlebars templates. It certainly doesn't subscribe to the idea that you should have handlebars in Jade. The thinking is that you should have HTML, and essentially browsers should be able to look at curly braces, or should give you the machinery you need to implement templates that way. So I'm kind of keeping an eye on it. I haven't seen anything that makes me want to jump on those technologies and syntaxes. I think there's a lot of stuff wrapped up in there that would be really great to see in browsers, though. Like the ability to parse HTML in the browser, but not evaluate the things that usually get evaluated. Like part of the challenge for them is if you have like an image tag and you have some template in the source field, well, usually a browser will start fetching the image as soon as the image tag is created. So one of the proposed browser extensions is put the browser in a mode where you can construct tags and not have them immediately do whatever that tag would normally do. Another is a system that's kind of like live range, where you can track parts of the DOM, but the browser will do it for you. But they can't be empty, and there's certain restrictions there. I'd love to see that in browsers. So I'm just going to kind of see what happens with that. I think custom elements are one way to express components. Our syntax is one way, and there's plenty of time to for it all to come together somehow.
We're going to take one question from Twitter. Josh from Vancouver has a question. Session is a global var, and that would normally be an anti-pattern, but seems to be used a lot in Meteor. Other approaches, question mark?
Yeah, I don't have to repeat that question, right?
No.
Yeah, we want to have a reactive state that's not global, that's scoped to a template. And I think the only reason we don't have that yet is just it's a hard design problem about how does that get initialized, how do you use it from handlebars. So something we're thinking about. I think we probably would have, if you'd asked us, some months back, we probably would have expected to have an answer to that by now. It turns out you can actually do a lot with session, especially if you generate strings to use as session keys. It's kind of a pain. We're gonna have an answer for that basically as soon as we can get it out. As soon as we can figure out what our answer to that is.
Cool. Thank you, David.
Thank you.